Everybody is welcome to my YouTube channel on the topics of BOYCE CODD NORMAL FORM, BCNF. Before going to the BOYCE CODD NORMAL FORM, I am discussing the first normal form of the database management system. What is the first normal form? When the normal form is not satisfying the atomicity, that is, composite value is showing up any row, up any column, that is not in first normal form. So you have to remove the duplicate or composite value. You have to show the only one single value of each column. So each column a single value, that is this table student, also showing the composite value of composite phone number of the student. After removing, we are getting the first normal form, and row is increasing. Row is also increased for the duplicate phone number. So this is the first normal form of the table, but there are redundancy. Redundancy is a focus of the normalization. Normalization is required to reduce the redundancy. Is the first criteria. And now I am coming second normal form. Second normal form where the table showing student ID, course number, and this student ID and course number is a composite candidate key. And another table, another activity is course fee. Student ID and course number is dependent, and course fee is dependent on the student course number, not both key. But this is the problem here at the second normal form, when the non-prime attribute, that is here course fee, is partially dependent on the candidate key. That is, course fee is dependent on the candidate key, not both key, but single candidate key, that is course number, where student ID and course number is a composite candidate key. So non-prime attribute is partially dependent on the candidate key, that is at the second normal form. So we have to remove the dependency, and we have to shift this dependency on the specific key, specific candidate key, or both key, or specific candidate key, not only single candidate key. So after removing, we are getting the table, two table, there is decomposition of the table. Whereas the two table, that is, one is student, another is course table. Student table contain student ID, course number, and course number and course fee, another table, course. So table is decomposed, and the decomposed table is separate to decomposed table. One common key is there, that is course number, and this common key consists some information, common key for the information, join information, and two primary keys there of each at the table, student ID, and another is course number. So this is the decomposition. After decomposition, we are the decomposition after the partial dependency is already destroyed. Now we are coming the third normal form. This normal form is bearing the dependency of transit dependency. Transit dependency means when A determines the B, and A determines C, and B determines C. When non-key attribute is dependent on the key attribute. When transit dependency is appeared. So non-key attribute is dependent on the non-key attribute. It is the main cause of this transit dependency. Now the table showing three column: EMP ID, EMP name, এবং department DAP name. EMP ID is uniquely identified the EMP name, and also EMP ID uniquely identified the department name. So EMP ID is a primary key to identify EMP name and also department name. And EMP name, department name, both are non-key attribute. But both those two non-key attribute have a figure of the dependency. How? EMP name is identified the department DAPT name. So non-key attribute is dependent to each other. So this is the normal form that is bearing at third normal form. And we have to decompose the table, and we have to create the two separate table. One is EMP ID with EMP name, another is EMP name with DEPT name, department name. And EMP name is common attribute for the making relation and for report. And so third normal form, after third normal form, the transit dependency is removed. And where transit dependency means non-key attribute is dependent on the non-key attribute. This problem is already removed from after the end of third normal form. And now we are coming BOYCE code normal form. BOYCE code normal form where only one condition is there, that is the determinant must be the super key. X is determining the Y, and X must be the super key of this relation. Suppose the relation here it is showing R, that is ABCD is the attribute of the relation R, and functional dependency of this attribute is B is determining C determining A, and C determining D also. This is the fundamental functional dependency. Now we have to find out the closure of the element. First element B. So we have find out the element B, closure of the element B. How to find out the closure of the element B? B is identifying C is identifying A, C is identifying D. So B is identifying C, C is identifying A. So A is also identifying, and also C is identifying D. So B closure is BCAD. That is all attribute of the relation is present at the B closure. So B is a super key of this relation. Now the closure C showing that C determining A, and C is also determinant of the D. So C, the closure of C showing three elements, C, A, D. So this is not a super key of the relation. Problem is at that point. That is the point, the relation which is not maintaining or which is not showing the super key. That is a problem. So I am taking this relation C equal to CAD, and I am breaking this table, this relation. So two table is formed, two relation is formed. First relation, total relation was R, A, B, C, D, and now relation is already organized. R, C, A, D, which is a faulty, where there is not a super key, and another relation R to B, C, where R to B, C is a rest relation. So why I am taking R to B, C? Because C is a common attribute for making relation of the table, and B is a key, super key. So with super key, common attributes are adjust, and a relation is formed, that is R2, and another relation R1 CAD is formed. So two relation already come at the BCNF position of the BCNF last point. So two relation R2BC and R1CAD is the final relation of the BCNF for the new table formation. Now we coming another example of the example is company, that is the name of the relation, and the attributes are EMP ID, EMP name, E name, and com ID, duration. Duration means how many hours the worker is working. Now we see that EMP ID identifying EMP name and EMP mail. So EMP ID is the primary key of the two attribute, that is EMP mail and EMP name. Another attribute, another matter is the EMP ID and com ID, company ID, both identifying the duration, that is the period of working workers. So duration is dependent on the both key, that is EMP ID and com ID. So we can say that EMP ID and com ID combine super key. This is the violation of BCNF. So how we have to do? we have to remove this relation. So the two relation, one is EMP ID, EMP name, and E name is formed, relation name R1, and another relation R2, taking EMP ID, COM ID, and duration is formed. Two relation is formed, and both relations is at the last position, last point of the BCNF. So the BCNF at the position of the last position of BCNF, we have gained the two relation after decomposing the one relation of the main relation, that is two relation is R1 and R2, and it is removing the axing point, which was most axing condition of this BCNF form. And now we are coming to the next another example, that is R equal to LMNOP. LMNOP, this is a relation, and fundamental functional dependency is L determining Mn, NO determining P, M determining O, and P determining L. Though we have to find out the closure. The L closure showing L determining Mn, also MNOP. So L closure showing Mn, LMNOP. This is the all representative, all the attribute is present here. So this is a super key attribute. Now we are coming NO. NO identifying P, also L, also M. So NO also showing the all attributes of the relation NO, P, L, M, LMN, OP. So this is also showing the super key character. Another is M. This relation M, this closure of the M showing only MO. Or M identifying only one identifier attribute, that is O. So MO. This relation, it is not showing any super key character. So this is only character, only relation that is not showing the super key. Another relation is there. Another closure of the P is showing the all attribute P, L, M, N, O. So only one relation M, it is not showing as a super key. So we have to take this relation. Who is not showing the super key? We have to take this relation. So L, LO, P is showing the super key, and already I have taken the relation M, MO. M identifying MO. And the main relation was R, LM, OP. This is the main relation, and decomposing after decomposing, I am getting the two another relation R1 and R2. R was showing MO containing M and O2 attribute, and R2 showing L, M, N, C attribute. But this relation R2 element is not the final relation of the BCNF, because this is not maintaining the BCNF condition. So I have to break this relation element, and also two other relation I am getting, that is R21 containing LMN attribute, another relation R22 containing two attribute LP. So finally we have already taken the three relation R1, R21, and R22. Three relations is the final relation of the BCNF conformation, BCNF structure. Now we see that is the relation. We are breaking the relation. We are creating the so many tables at the end of the relation. So what we are gaining? If we are getting first point is redundancy. Redundancy is vanishing. Redundancy, the point was most axing point was redundancy reducing. So it is reducing the redundancy. And there was some another graph we have already representing, that is first NF, second NF, third NF, and BCNF. From first NF to BCNF. First NF to BCNF, redundancy is losing. First NF to BCNF, redundancy is losing. And BCNF to first NF, redundancy is increasing. So first NF to BCNF, redundancy is losing, and BCNF to first NF, redundancy is increasing. And from first NF to second NF, the redundancy is losing, and also it is right that when any form at the first NF, it is not second NF. When any form is second NF, it is first NF. It must be at first NF. When any form at the third NF, it may not be that. It is at the it is must be that second NF. And but second NF any form, it may not be, but it never be third NF. If it is from any BSNF, B is BCNF portion, then this relation must be at CDNF. But if any relation are existing at BCNF, it is not right that it would be CNF. So this type of relation, when first NF to BCNF, it is compulsory. The relation is reducing the redundancy, and from BCNF to first NF, redundancy relation is increasing the redundancy. If any form we get from BCNF, it must be third NF, it must be second NF, it must be first NF. But first, any form at first NF, it may not be second NF, it may not be third NF, also the BCNF. So this is the end of my video, and everybody requested, please subscribe this channel for the latest video.